Good evening, guys. Are you able to hear me?
Yes, sir.
Yes, sir. Okay.
Yes, sir.
So we'll get started. Listen. So what was the last topic we were discussing?
We are doing the associative and distributive loss.
With respect to
Addition and subtraction.
multiplication.
I think it was addition with subtractions.
Okay. One minute.
And you also told us about inverse.
Yeah. So for 12. No. Yeah. So we have seen properties of multiplication. Like we started with multiplication, right?
Yes, sir.
Okay. Did we see any example problem last class?
Yes, sir. We did one example. I think.
I think that was easy only, right? Okay. Next, we'll start with the properties of matrices. Sorry, multiplication of matrices. So, what are all the properties associated with it? One is the associative law. So, if suppose three matrices are given to you, A, B, C, then if you multiply AB first and then multiply that with C, or multiply A with the product of B and C, then they are equal. Right? Provided what should happen? They should be satisfying the condition of multiplication of matrices. So what is the condition for multiplication of matrices, guys? Number of
Columns in the first matrix should be the number of rows
yes.
in the second matrix.
Number of columns in first should be equal to number of rows in second. Correct? Next is the distributive law. So what does the distributive law say? So distributive law says if you multiply A with the sum of B and C, or multiply AB separately and AC separately and add them, they both will give you the same value. Similarly, if you add A and B and multiply with C post multiplication, then AC plus BC will also give you the same value. Okay. Then what about the multiplicative identity, guys? So what do you mean by multiplicative identity? For every square matrix, you cannot have it for every matrix. So multiplicative identity means you need an identity matrix. By default, what is an identity matrix? It is a scalar matrix. right? So for every square matrix A, there will exist an identity matrix of the same order such that the product of I and A, the identity matrix and the given matrix is the same as A into I is the same as A. So this is the only place where commutative law also works. Okay. So example number 16. Can you guys do it fast just for my satisfaction? I know most of you have solved this, but do it fast and tell me if it is working or not. Just tell me the final outputs. Just tell me the final output. That's enough.
So I got 2, 1, minus 1, 18, 150.
2, 1, minus 1.
2, 1, then next 2, minus 1, 18, and then 150 for AB, sir.
By 80 and dollar coming. I didn't get you. Your voice was breaking. Sorry. Can you repeat it again? 2?
I got for A into B, sir. I got,
You got
2,
only
1.
A?
Yes, only for A into B.
Okay, I want the final answer. The calculation stuff. Okay, but everybody knows the method to do it, right?
Yes, sir.
Okay. So this is the answer I was asking. Okay, all these are just like you need to verify those properties. You can try them out. Okay. This problem alone will do it. So A is equal to 1, 2, 3, 3 minus 2 and 1, 4 to 1. Then show that A cube minus 23A minus 40I is equal to 0 matrix. Okay. So what is A square, guys? A square is A multiplied with A itself. So it is 1, 2, 3, 3 minus 2, 1, 4 to 1 multiplied with 1, 2, 3, 3 minus 2, 1 and 4 to 1. Okay. So what is A square now? 1 plus 6 plus 12 and 2 minus 4 plus 6. Oh, sorry. 3 minus 6 plus 4. Then what am I doing?
That's 2 minus 4 plus 6.
2 minus 4 plus 6 only. Yeah. 3 plus 2 plus 3. Okay. Now, the next row is 3 minus 6
Plus
plus 4. Correct. So then we have 6 plus 4 plus 2. Then we have 9
minus 2 plus 1.
Yes. Then you have
4 plus 6
60.
plus
4 plus 6 plus 4. Then tell me that. 8 minus 4 plus 2. 12 plus 2 plus 2 plus 2. 2, oh, 1. Sorry. Yeah. So how much are we going to get? There's how much? 19.
Yes, sir.
So 19. There's going to
4.
be 4, 8. Correct? So 7 minus 1, 7 minus 6, 1. 10, 12. 9 minus 2 is 7 plus 1, 8. 10, 16. Sorry, 16. 14. 10 minus 4, 6. 12 plus 2, 14, 15. Right? This thing should be multiplied with A again. Then you will get A cube. Then this will give you the answer. Right? Then you have A cube in your hand. A is already a question. 40 times I. I is the identity matrix. Then what will happen when you multiply 23 with A, guys? Every element will get multiplied with 23. After that, you need to add all the corresponding elements of the given row. Then you will get the final answer. And it should be a null matrix or a 0 matrix. This part, I hope you guys can solve it, right?
Yes, sir.
Next. Next. In a legislative assembly election, a political group hired a public relations firm to promote its candidate in 3 ways. One is telephone, house calls, and letters. The cost per contact in paise is given in a matrix as A is equal to 40 pice per contact when it is a telephone marketing, 100 pice per contact when it is a house call, and 50 pice per contact when it is a letter marketing. So the number of contacts of each type made in the two cities are X and Y that are given as B is equal to 1000, 500, 5000, 3000, 1000, and 10,000. Okay. Find the total amount spent in the two group spent by the group in the two cities X and Y. So what is going to be the total amount, guys? So total amount basically is nothing but, so if I say total amount in the phone call, then how will you say? Phone call in city X. Assume this to be an Excel sheet. Okay. If I say total amount for spent for the phone call in city X, what will you say? So how many people are there?
1000, sir.
1000 into per each person, how much are they spending?
40.
40. So it is going to be 40,000 paise, or divided with 100, it is going to be 400 rupees. Yeah, they're able to understand. So instead of doing this, what are we supposed to do? So number of contacts multiplied with the amount for each marketing method is going to give you the total amount. So if you observe, this has 3 rows and 2 rows and 3 columns. And this one has 3 rows and 1 column. So will you multiply A with B or B with A? Columns in the first matrix should be equal to the number of rows in the second matrix. So columns in first matrix is 3, rows in the second matrix is 3. So you have to only perform the operation B into A. When you do that B into A, how much are you going to get? 40,000. So what will be the matrix that you will get, guys? You will get a 2 cross 1 matrix. Right.
Yes, sir.
So 40,000 plus 50,000 plus
25,000.
yeah,
250,000.
Is it not 250? Yeah,
Yes, sir.
250,000. And next, telephone, the second case is 12,000. 12,000 or yeah, 40,000. Yeah, 12,000. Then you have 100,000, that is 1 lakh. And the last one you have 5 lakhs. Okay, now you add them, you're going to get the answer. What is the answer in the first case? You will get 3,40,000. In the second case, you will get 7,20,000. So they have spent these amounts in the cities X and Y respectively. They are not in rupees, they are in terms of paise. That's what we need to keep in mind. Right. So let's see. These problems are all easy only. You guys can do it. For that matter, every problem is going to be easy only. We'll do sixth problem. I'll do it first. So what is the answer for the sixth problem? Cos theta multiplied with the whole matrix. You will get cos square theta plus cos theta into sin theta minus cos theta sin theta plus cos square theta. That is the first matrix. Plus, what is going to be the second matrix? Sin square theta,
minus sin theta cos theta, then plus cos theta
sin theta cos theta,
plus
and sin
sin
square
square
theta.
theta.
Okay. So add both. Cos square theta plus sin square theta is 1. Cos theta sin theta minus sin theta cos theta 0. Cos theta sin minus cos theta sin theta plus sin theta cos theta 0. Again, cos square theta plus sin square theta is 1. You get an identity matrix of order 2. Okay. Find x and y. How will you find the problem? How will you solve this problem? So how to solve this problem, guys? Make it fast.
Elimination or substitution.
Yeah.
Or
You add them. So 2 times matrix X is equal to, add the corresponding element. 7 plus 3 is 10. 0, 2, 8. This is 2x. So x will be how much? 5014. Right. In a similar way, if you subtract them, 2y will be equal to 7 minus 3 is 4, 0, 2, 2. Y is equal to 2, 0, 1, 1. Simple. Similar is the case with this. So 2x plus 3y is equal to something, 3x plus 2y is equal to some other matrix. Then how will you find the value of x and y? So treat them like two linear equations, use the elimination method and solve it. Will you guys be able to manage?
Yes, sir.
Okay. Let's do 13th one. Okay. So f of x is equal to cos x minus sin x 0. Let's do it separately. Wait. Guys, tell me what is f of x into f of y? So cos x minus sin x 0, sin x cos x 0, 0, 0, 1 into, tell me, cos y minus sin y 0, sin y cos y 0, 0, 0, 1. Correct? So when we multiply them, what do we get? Cos x cos y, cos x cos y minus sin x sin y plus 0. So that is the first element. Second element is minus cos x sin y minus sin x cos y plus 0. And the third element is obviously a 0. Okay. Second row, first element. Then you will have 0 plus 0 plus 0. Here you will have 1. Okay. So cos x cos y minus sin x sin y. What is it, guys? It is cos of x plus y. Minus cos x cos y minus sin x sin y. Is it not minus sin of x plus y? And the third element is 0. Sin x cos y plus cos x sin y. It is sin of x plus y. Cos x cos y minus sin x sin y is cos of x plus y. This will be 0. 0, 0, 1. Is this f of x plus y? Yes, yes. Did you guys understood what is f of x plus y? So in the place of x, I should have x plus y. So f of x plus y will be cos of x plus y minus sin of x plus y 0. Similarly, sin of x plus y, cos of x plus y 0, 0, 0 and 1. Here, guys.
Clear, sir.
Yes, sir.
So all these problems are again simple. Okay, let's do the 17th one. If A is equal to 3 minus 2, 4 minus 2, I is equal to 1001, then find the value of K so that A square is equal to K times A minus 2I. So how to find, guys? So A is given. What is A square? Nine minus 8 minus 6 plus 4, 12 minus 8 minus 8 plus 4. So this will be 1 minus 2, 4 and minus 4. This is A square. So can I write, when A square is equal to K times A minus 2I, can I write A square plus 2I is equal to K times A? So A square is 1 minus 2, 4 minus 4 plus 2I will be 2002 is equal to K times, what is the value of A? 3 minus 2, 4 minus 2. What is the answer, guys? 2 minus 2, 4, so 2 the 3. So 3 minus 2, 4 minus 2 is equal to K into. So what will be the answer? You take any one of the number. 3K is equal to 3, K will be equal to 1. Okay. So other problems, I hope you guys can do it right. You will try. If there is any doubt, reach out to me. Okay. Shall we move on to the next concept? Next is transpose of a matrix. So what do you mean by transpose?
Rows becomes column and column becomes.
That is, yes. If there is an interchanging taking place between the rows and the columns, then we call it as a transpose. See, for example, you're able to see my screen, right? It's something like this. So now we are seeing a rectangle. There is a rectangle with more number of rows or columns. This is a rectangle with more number of rows or columns. So these are columns, right? So if I keep drawing these arrow marks with equal spacing, will I be able to draw more number of columns or more number of rows?
Columns.
Yes. Whereas if I rotate it like this, what will happen?
Number
Then you
of
can draw
rows,
more.
less number of columns.
So this is something like transpose. Okay. There is an example for you to visualize what exactly it means. Okay. So transpose of a matrix is generally is the matrix which is obtained by interchanging the rows and columns of the given matrix A. So if A is a matrix where the elements are having the form Aij and the order is m cross n, then A transpose will be what? It will be a matrix with the elements A, J, I, and they will be of the order n by m. And how is it obtained? By just changing the rows into columns and the columns into rows. So A is equal to what? Where do you use this transpose in next chapter? Can someone tell me? Where do you use the concept of transpose in next chapter?
Sir, can I repeat again, sir?
Finding the adjoint.
I'm asking, which one should I repeat? Huh? The Nicholas, that's right, to find the adjoint. Yeah, Mithil, which one should I repeat?
So the transpose thing, sir. Actually, my network was fluctuating, sir. I was not able to see it clearly, sir. Now you said something, no, sir. That one, please.
No, transpose. I asked where do you apply it in the next chapter? It is to find the adjoint of a given matrix.
Okay, sir. I thought
Okay.
something important.
No. I just wanted to check if you guys know it or not. So properties of transpose of matrices. Okay. So what are all the properties? If A and B are matrices of suitable order. So for transpose of a matrix to occur, you can have a rectangular matrix also. There is no necessity of you having a square matrix alone. Okay. So if you find the transpose of a transpose, so if A is a given matrix and you find the transpose of it and you find the transpose of it again. See, generally in some books, it's written A power T also. A power T also represents transpose, or some books write it as A dash, like how it is written here. They both mean transpose only. Okay. So the transpose of a transpose is the matrix itself. Okay. Secondly, if any matrix is multiplied with the number k with a scalar value and you take the transpose of it, it is the same as multiplying the scalar with the transpose of that matrix. So k times A transpose is the same as k into A transpose. That is what I'm trying to say. Okay. Third, if you have the sum of two matrices and you take the transpose of it, it is the same as taking the sum of the matrices individually and adding them. Okay. Whereas in the case of multiplication, what will happen? A transpose into B transpose will be exactly equal to, AB the whole transpose. That is, you have the product of A and D and you take the transpose of it, that will be equal to B transpose into A transpose. Okay, these are all the properties. So all these properties generally come from observation. Can you guys think of the logic for it? AB the whole transpose is equal to B transpose into A transpose. Why? Let's say the A is a matrix of order m by n, and B should be a matrix of what order? It should be n by something, n by B. Then A into B will be a matrix of order n cross. Yes. Then AB transpose will be of an order P cross. Okay. I'm just telling you the logic with respect to the orders. Now, if A has an order of m by n, A transpose will have an order of n by m. Right? If B has a order of n by P, then B transpose will have an order of P by n. Now, which two matrices are feasible? Which is the order in which you have the feasibility to multiply with respect to transposes? Can you multiply A transpose into B transpose? Obviously, no, because the number of columns here are different. Whereas if you do B transpose into A transpose, yes, what will you get? You will get a matrix of order P by M. So something like this. I tried to explain with the help of order, but if you take an example and do and see, you will get the same thing. Now you guys are able to understand why in the case of transpose they are in the reverse direction. I'm sure you guys would have applied it already. If you already know the logic, it is well and good. But is it clear?
Clear, sir.
Good. So you guys will try these problems, right? No. So 21st is they want us to verify the property of the matrix. AB the whole transpose is equal to B transpose into A transpose. You can verify it. It's a simple thing. So what you order in the steps to be solved is, step 1 is find AB. Step 2 is find AB transpose and call it as equation number 1. Step 3, find B transpose. Step 4, find A transpose. Step 5, find B transpose into A transpose and call it as equation number 2. If 2 is equal to 1, then the statement is right. That's it. Okay. So moving on to the next part. So now you guys tell me, what do you mean by symmetric and skew symmetric matrices?
So symmetric means transpose will be equal. Skew means the negative of the transpose will be equal, sir.
So if you have a square matrix, right? So generally, since you're saying that symmetric and skew symmetric are related to the matrix and the transpose of the matrix itself, and the equality or the opposite sign. That is whether they both are like A is equal to A transpose or A is equal to negative of A transpose. This is possible. You can equate two matrices only when they are of, or the first thing that should get satisfied. Two matrices can be equated only if they have the same
Order.
right? Whereas we know the transpose can be defined also for a rectangular matrix, right? So generally what will happen for a rectangular matrix is, if it is a 2 by 3 matrix, then this will become 3 by 2 matrix. Is there a question of equality? Guys, are you able to understand what I'm asking? Will you be able to say in this scenario, will you be able to say that A is equal to A transpose? Obviously no, right? Because they both are of different orders. So in order to get this kind of a scenario, what are we supposed to do? We are supposed to choose only those matrices so that the transpose and the matrix itself are having the same order. When is it possible? Only when it is a square matrix. Are you guys able to understand why only square matrix should be considered? So a square matrix is said to be symmetric under what scenario? Then symmetric is a technical name. A square matrix is said to be symmetric because when the A transpose is equal to A. Okay, so that is when all the elements in which in the matrix A and all the elements in the matrix A transpose, where they both are same, then you call it as a symmetric matrix. Right? Example: root 3, 2, 3, 2 minus 1, 0.5 minus 1, 3 minus 1, 1. So how do you write the transpose for it? So generally, whenever you are writing the transpose for a square matrix, which part will be undisturbed? Root 3 minus 1.5, 1. That is, the diagonal elements are untouched. They are not changing. But what will happen? This 2 will come here and this 2 will go here. So 2 and 2. This 3 will come here and this 3 will go here. 3, 3. This 1 will come here and this 1 will go here. Minus 1, minus 1. So these two matrices are said to be symmetric. Now, what is skew symmetric? Obviously, a known thing. So skew symmetric also you need a square matrix. So a square matrix is said to be skew symmetric if the transpose of A is equal to the negative of A. Okay. So for that, we need to consider a matrix like this. Right. See, one point you should have in your mind. What kind of a matrix are we considering? Guys, I want you to answer for this logic. We understood. What kind of a matrix are we considering for symmetric and skew symmetric? First condition is it should be a square matrix. Correct? Secondly, for a square matrix, when you write the transpose, which line does not change?
The diagonal.
Diagonal. So diagonal means when you take it from the left to the right along the cross, right? So when you take it along this diagonal, the values do not change. So skew symmetric also has something to do with transpose, but A transpose should be the negative of A. So when you write transpose, since the elements along the diagonal are not changing, then skew symmetric says that when you write the transpose, you should get the negative of A. If you have some non-zero number here, then the negative of these non-zero numbers will be the exactly reverse of them. So in order for you to ensure that there is a skew symmetric matrix existing for a given matrix, it is compulsory that these diagonal elements are supposed to be, it is mandatory that these diagonal elements are supposed to be, please fill in the blank. Guys, are you able to understand my logic or not? Or else you already know the answer.
Could you repeat?
I'm saying, see, for example, I'm taking a matrix like this. A, B, C, E minus E, F minus F, G minus G. Okay. This is the matrix A. It's a square matrix, so I can define the skew symmetric condition. So if I take the transpose of it, what do I get? A, B, C are undisturbed. So here you will have E, here you will have minus E. Here you will have F, here you will have minus F, here you will have minus G, here you will have G. I hope this point is clear. Right? But for me to call it as skew symmetric matrix, for me to call this matrix A as skew symmetric, then the transpose should be the negative of the original matrix. So what are the negative of the original matrix? Minus A, minus B, minus C. But everything else, if you observe E minus E, F minus F, G minus G. If you observe, negative of A and A are almost looking the same. But what is the difference? What is happening to the diagonal elements?
The sign is different.
The sign is changing, right? So what is the only number that is possible where you can't change the sign whether you multiply with positive or negative? It is 0. So for any matrix to be defined as a skew symmetric matrix, it is compulsory that all the diagonal elements are supposed to be 0. Is that clear? It's an important
Yes, sir.
condition. Please make a note of it. Okay. All the diagonal elements of a skew symmetric matrix are 0. They are supposed to be 0 only because of this logic. Okay, there are some simple theorems. So the theorem 1 is, for any square matrix A with the real entries, A plus A transpose is always a symmetric matrix and A minus A transpose is a skew symmetric matrix. Are you guys able to understand this? So if you have a square matrix A, then the sum of the matrix A with the transpose of it is always symmetric. Whereas the sum of the matrix with the negative of the transpose of it is always skew symmetric. Okay, that is first thing. The second theorem is, if you have any square matrix, then you can represent that any square matrix as the sum of a symmetric and a skew symmetric matrix. So can I write A is equal to A plus A transpose plus A minus A transpose? Right? So that A transpose gets cancelled. Correct, Ada? But what will I be left with? If I add everything, Left hand side is A, but the right hand side will be 2A. So I need to compensate it with a 2. Correct? But according to theorem number 1, for a given square matrix, A plus A transpose is always symmetric, and A minus A transpose is always skew symmetric. So what will happen? You can write the given matrix A as half of A plus A transpose plus half of A minus A transpose. So that is the meaning of any square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix. Okay. So can you guys try this problem and tell me? Matrix B is 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3. Express this as a sum of symmetric and skew symmetric matrix. So what is B transpose? 2 3 minus 3 is undisturbed minus minus 1 minus 2 minus 4 1 minus 2 4. Okay. So what is B plus B transpose? So B plus B transpose divided by 2 is how much? Divided by 2 is 2 minus 3 by 2 minus 3 by 2 minus 3 by 2 3 1 minus 3 by 2 1 3. So this is B plus B dash by 2. Similarly, find out B minus B dash by 2. Then what you can do is express B as the sum of these two values. That will be the answer.
So is it always necessary to find P dash and Q dash?
Is it?
Always necessary to find P dash and Q dash?
I mean, you're saying we need to find it twice.
So like we check P dash is equal to P to say it's symmetric, right? So
No. That is a mistake. See, that is not the question. Here, the question is not about asking you to verify. If you read the question carefully, they are not bothered about whether whether matrix B is a symmetric matrix. They want you to express the matrix B as the sum of a symmetric and skew symmetric matrix. So, according to theorem number 1, listen to this carefully. If I give you a square matrix and I ask you to form a matrix which is symmetric. So, how many matrices did I give you? I gave you only one square matrix. And when I take only one square matrix, there is a high possibility that it is neither symmetric nor skew symmetric. For example, okay, I'll explain it clearly. So I have a matrix like this: 1, 2, 3, 3, 4, 5, 2, 3, 1. Okay. Is it symmetric?
we have to check, sir.
Check it, no? 1, 4, 1, 3, 2, 2, 3, 5, 3. Now you tell, is it symmetric?
No, sir.
Obviously no, right? But what does theorem 1 tell us is, if I give you any random square matrix, you can always form a symmetric matrix from it by taking the sum of the given matrix with the transpose of it. Now I'm going to add these two. Okay. What is A plus A transpose? Tell this. Make it fast.
2, 5, 5,
Mm-hmm.
5, 8, 8,
588
5, 8,
5, 8, 2.
2. Okay. Now, what is A? So I will call this matrix as C. Okay. What is A plus A transpose matrix transpose? That is, I'm asking what is C transpose? 282 555 885. Now tell me whether C is a symmetric matrix.
Yes, sir.
That is the meaning of theorem 1. So if I give you any square matrix, okay, I repeat, any square matrix means it need not be symmetric, it need not be skew symmetric also. It's just some random square matrix. Then to the given square matrix, if you add the transpose of it, then you will get a new matrix, right, which is C. Then the new matrix which you are getting will always be symmetric.
Okay, sir. I understood.
Okay. Now, similarly, if you take the difference of these two differences, I mean, subtract the transpose from the given matrix, A minus A transpose. Don't do A transpose minus transpose. So, A minus A transpose is what?
Zero, minus 1, 1.
A minus A transpose is, tell me, 0, minus 1.
Minus 1, 1.
Okay.
1, 0, 2.
Okay. Minus 1.
Minus 1, minus 2, 0.
Okay. Then this A minus A transpose, I call it as D. Okay. Then what is D transpose?
Be the same thing, but signs are changed.
0, 0, 0, minus 1, 1, 1, minus 1, minus 2, 2. Okay. Now, negative of D transpose is 0, minus 1, 1, 1, 0, 2, minus 1, minus 2, 0. Correct? So, negative of D transpose, is it not the same as A minus A transpose? That is D.
Yes, sir.
So, it is a skew symmetric matrix. Now, what they are asking is, in this question, if I give you a random matrix B, if you observe, it will neither be symmetric nor skew symmetric. But how can you make this matrix B as a symmetric matrix? By adding it to the transpose of the given matrix. Similarly, if you subtract the transpose of the given matrix from the matrix itself, you will get skew symmetric. And according to theorem 2, any matrix A can be written as half into A plus A dash plus half into A minus A dash, where A plus A dash is symmetric, A minus A dash is skew symmetric, and this is what they are asking in the question. So B has
Okay,
to be
sir, I
written as
understood.
half into B plus B transpose plus half into B minus B transpose. Okay, so that is why we found B plus B transpose and B minus B transpose, divided both and wrote it. Actually, yeah. I hope it is clear now, right?
Yes, sir.
Yeah. So these kind of questions will also come. And with respect, so the last topic that is left out in this chapter is inverse and elementary operation. Since I have already recorded the video, you guys can go through it and come before tomorrow's class. Okay. We'll do more of problems and I'll teach you some important problems. With that, this chapter will be over. Then we can go to determinants.
Okay, sir.
Okay, then. I'll see you.
Thank you, sir.
Thank you.
Thank you, sir. Thank you.
Thank you, sir.
Yeah.